Hi, I'm Professor Clements. Today we're going to talk a little bit about scientific notation. Now the first thing about scientific notation is why do we want to use it? And mainly it's so that if we have numbers that are fairly large, right, we've got lots and lots of numbers in there, it's kind of hard to figure out what that number is. Certainly, what we do usually is we count back by threes and we draw our commas there, and so we know that's about 120 million. And so that's how we figure out how big that number is. But it involves counting zeros or having those commas there to help us. But one thing we can do in scientific notation is we can represent this as the important parts, right? That we know there's a 12 in there somewhere. There's a 1 and a 2. And then we want to know how big is that 1 and that 2. And that's what scientific notation does. And so I'm just going to represent it first and then show you how to do that. How we'd represent this number in scientific notation is we say that's 1.2 times 10 to the 3, 6, 7, 8. And you saw me counting digits there. I kind of moved my hand around, and I'll show you what I do in order to do that. So this is 1.2 times 10 to the 8th. The 1.2 tells us the numbers we measured, and the 10 to the 8th tells us something about how big they are. So we know this is a very big number. It's in the hundreds of millions. So how did we go about doing that? Well, if you want to take a big number and you want to write it in scientific notation, what you're going to be doing is you're going to take whatever number, so let's do another one here, where it's 345,000. Okay? And there's two parts of scientific notation. There's what's called the coefficient. I don't have enough space, so I'm just going to write coefficient there as an abbreviation. And there's what's called the exponent. Right? And that's what we have, the 10 to the 8th there. So again, the coefficient tells us the number we measured. The exponent tells us how big is that number. So if we have this number like here, 345,000, what we want to do for the coefficient is we want to get all the significant figures in there. Now, I have another video on significant figures, so if you aren't sure what I mean by that, you want to check out that video. But we want to get all the significant figures in there. And then we want to use the exponent to say how big that is. So what we're going to do is we're going to pretend that there's a decimal point here. We're going to pretend there's a decimal point there. And then I'm going to start moving over that decimal point. So if I move the decimal point over there, I would change from 345,000 to 34,500 if I moved the decimal point over, right? I have a 0 there. So that's kind of what I did. Now, obviously 34,500 and 345,000 are not the same number. And so what do I need to do? Well, this number, 34,500, is 345,000 divided by 10. So if I want to make them equal, I'm going to say multiplied by 10. And that's all we're doing in scientific notation, is we're actually multiplying by 10. Now I'm going to kind of go upwards here as I go along. I'm going to move that again, and now I've got the number 3,450. And I've got a couple digits after there because I moved that decimal again. Well, remember, I already had the times 10 here. Now what do I do to get these two numbers to be equal? Well, to get 3,450 to be equal to 34,500, I need to multiply by 10 again. And so now I've actually multiplied by 10 twice. And that's what we keep doing in scientific notation. Now, how can we represent this in a different way? We say 3,450. I'm going to put these decimals here, times 10 to the second. Now, I started to say I'm going to put these decimals here, but we're only doing this to show how scientific notation works. One thing that's important to remember about scientific notation is the number of sig figs that you start with has to be the number of significant figures that you end with. But what I'm going to do is keep moving this decimal place over, and for every place I move it over, I need to increase my exponent by 1. So if I move it 1, 2, 3 more over, and I get 3.45. Now I'm not going to write any of these zeros here because these zeros were not significant in my original number. And times 10 to the, and then I just count how many times did I move that decimal point over. And if I start from the beginning here, I moved it 1, 2, 3, 4, 5. So I say this number is 3.45 times 10 to the 5th. And as we did it kind of in a circle, but hopefully you got what I meant by that. So large numbers in scientific notation, you're going to be starting, put a decimal there, and counting backwards. Now, what if we had a number that already had a decimal point in it? What are we going to do? Well, it turns out exactly the same thing we just did now. So let me go ahead and erase this. It takes a little while on this board. Okay, so we're going to do the same thing we just did. So what if I have a number, oh, say 127.53, and I wanted to represent that in scientific notation? I'm going to do the exact same thing. I'm going to move my decimal point over 1 and multiply by 10, move my decimal point over another one and multiply by 10. And what I get is 1.2753 times 10 to the second. Since I moved the decimal point over 2 here, then I have a 10 to the second here. I had 5 significant figures here, and I have 5 significant figures here. That's important to keep all of your significant figures. Okay, so this is what we do for large numbers, and we'll go ahead and we'll do a separate video on what we do for small numbers. But that's how we're going to convert it. Let's do 1 or 2 more examples just to see. If we had the number 18,450, then what would we do? Well, we assume there's a decimal point here, and we're going to move it over 1, 2, 3, 4 to there, and we get 1.845. I'm not going to include that 0 in my number down here in my coefficient because it's not significant up here, so I shouldn't put it down here. Times 10 to the, we moved it 1, 2, 3, 4, and so we get 1.845 times 10 to the 4th, just like that. Okay, so that is how we're going to be doing scientific notation for large numbers, and we'll next see what we do for small numbers.